Welcome to the Explainer. Look, if you're building with AI right now, I'm willing to bet you know this painful, all too familiar story. You spend weeks choosing the absolute perfect model. You look at benchmarks, pricing spreadsheets, general vibes on Twitter. You wire up the API, test it out, and it looks amazing in a quick demo. But then you ship it, and the results in production are just totally disappointing. The large language model confidently spits out wrong answers. It entirely forgets things your users told it just 2 messages ago. It completely ignores those pristine documents you so carefully loaded into it. So, what do we actually do about this? Well, today we're going to diagnose exactly why your LLMs are confidently giving wrong answers in production, and more importantly, how to actually fix it. So, I have a question for you. Why exactly is your LLM hallucinating? When we face this kind of production failure, the diagnosis most teams jump to is almost always, oh, we just need a better model. But as our sources reveal, upgrading to the newest, GPT-4o, Claude, or Gemini, that is not going to magically make your problems disappear, because the model actually isn't your main problem. Here's our roadmap for today's explainer. We're going to start with the real LLM problem, distinguish context from prompt engineering, look at 3 common context failures, unpack the context engineering stack, and finish up with actionable steps to fix your context today. Let's dive right into Section 1, the real LLM problem, the symptoms and misdiagnosis. The actual diagnosis is almost always this. We need better context engineering, not a better model. Teams literally waste weeks obsessing over model selection and API wiring. But the real bottleneck? It's how they treat the context window. Right now, most teams treat the context window like a dumping ground. It's a bucket where they just throw in whatever seems vaguely relevant, kind of like keeping a shoebox full of crumpled receipts and expecting the model to act as your accountant. That might work for a flashy demo, but in production, it's the root cause of almost every single quality problem you're going to face. Enter context engineering. What is this exactly? Basically, it's the discipline of deliberately designing, structuring, and managing absolutely everything that goes into your LLM's context window to produce reliable, high-quality outputs. Think of it as treating your input pipeline as something you have to carefully architect, not just something you accumulate over time. This includes the system prompt, any data or documents you've injected, the conversation history, and the user's current message. The whole shebang needs to be engineered. I absolutely love this quote from our source material. Garbage in, garbage out is not a cliché here. It is the central engineering problem of production AI. The crucial takeaway is that modern frontier models are incredibly capable. The model is not the hard part. But what a model cannot do is reason well over bad inputs. It has no opinions about what's important in its context. It doesn't magically downweight stale information or flag contradictions for you. If you put noise in, the model is going to reason over that noise as if it were pure, unadulterated signal. Moving right along to Section 2, Context versus Prompt Engineering, Understanding the Difference. People throw these 2 terms around together all the time, but they are very distinct concepts. Prompt engineering is all about asking, how should I ask this? It focuses on how you phrase your instructions. Context engineering, on the other hand, asks, what should the model actually know when I ask it? It's about architecting the entire data pipeline so the right information is surrounding those instructions. When you break down the scope here, you really see the core difference. Prompt engineering focuses merely on the wording of the system prompt and the user message. Its primary lever is just text structure. But context engineering? Its scope is the full context pipeline, your retrieval, your history, your injection. Its primary levers are data quality, retrieval precision, and history management. Both of these matter, for sure, but if you're pulling your hair out over a production LLM failure right now, context engineering is exactly where your problem lives. Getting the model to reason over the right information is significantly harder than getting it to follow a well-phrased instruction. Which brings us to Section 3. 3 common context failures and exactly where teams go wrong. Failure number 1, treating retrieval, or RAG, as a simple checkbox. Teams often throw RAG together in an afternoon, see that it kind of works, and declare it done. But here's the terrifying part. Bad retrieval is actually worse than no retrieval at all. The model isn't going to raise its hand and tell you it couldn't find the relevant data. It will confidently construct a hallucination from the completely wrong document you just handed it. And that hallucination will look exactly like a grounded factual answer. It's not a missing feature, it's a massive failure to invest in the basic plumbing, things like your chunking strategy, metadata filtering, and result re-ranking. Let's look at failure number 2, letting conversation history just grow unmanaged. The absolute rookie way to build a chat interface is to append every single user message to the history and pass that giant, massive block of text to the model. This works fine until it completely breaks. Eventually, the history gets so long, it pushes the really important context right out of the effective attention window. The model literally starts acting like it has amnesia. But there's a more subtle danger too. Even before you hit token limits, a long, unmanaged history is just packed with noise. If a user changed their mind 3 messages ago, those old messages are now contradictory context the model has to resolve. And honestly, it usually fails to do so cleanly. So how do we fix that? You have to use approaches like a sliding window of just the most recent turns, or maybe periodic summarization of the older segments, or even selective retrieval, where you're only pulling the past turns that are semantically relevant to the current query. The big takeaway here is that conversation history has to be actively engineered, not just passively accumulated like some sort of data hoarding exercise. And failure number 3, writing the system prompt once and literally never touching it again. Most teams write their system prompt, telling the model who it is and how to behave, on day 1 of the project. Then they treat it like a static configuration file instead of dynamic code. This is such a massive missed opportunity. The system prompt is the highest leverage thing you can change to instantly improve your output quality. It matters way more than the model version. It matters more than your temperature settings. If you give a model precise constraints, like exactly what to do when it doesn't know an answer, or what specific format to use, it will radically outperform a vague prompt, no matter which underlying model you're running.
All right, section 4, the context engineering stack, building a pipeline.
If you're building a reliable AI product, you have to engineer 4 essential layers. Layer 1 is retrieval, pulling in the right documents with high precision. Layer 2 is injection, how that retrieved content is actually structured, ordered, and formatted to guide the model's attention. Layer 3 actively manages the history, windowing or summarizing it to resolve those contradictions we talked about. And Layer 4 provides the core instruction via the system prompt, constraints, and refusal rules. Amateur teams, they only think about Layer 1, retrieval. But shipping reliable, production-ready AI, that requires actively engineering all 4 of these layers.
Finally, section 5, steps to fix your context, the action plan.
Here is your 5-step checklist to start fixing this today. Step 1 is super unglamorous but incredibly vital. Read your prompts. And I don't mean the code that builds them. I mean log the actual raw string texts that get sent to the model and read them. You'd be shocked how many teams have never actually done this. Step 2, audit each layer of that stack we just discussed. Look for noise, contradictions, missing info. Step 3, fix your retrieval first. Step 4, restructure that system prompt to give explicit constraints and a defined output format. And step 5, add evals. Now, I want to pause on a magic number for a second. 30. Why 30? Well, for step 3, if you manually evaluate chunk relevance on just 20 to 30 real queries, you will immediately spot massive flaws. Adding a simple re-ranking step often produces a huge quality jump right there. And for step 5, building just 30 test cases with expected outputs, your evals, will immediately tighten your iteration loop. It lets you actually measure if your prompt changes are helping or hurting. Building those 30 evals is hands down the single most underrated investment you can make in your LLM's quality. So, I want to leave you with this provocative thought. Think about your current AI project for a second. When was the absolute last time you actually read the exact strings being sent to your model? Model choice totally still matters for things like extended reasoning or heavy code generation, but for most web integrations, the models we have today are already more than capable enough. The marginal gain you get from upgrading your model is tiny compared to fixing a broken retrieval pipeline or tightening up contradictory instructions. So seriously, stop shopping around for new models, roll up your sleeves, and start debugging your context today. Thanks for joining me on this explainer.